We're going to be looking at Chapter 13 now, and Chapter 13 is talking about personal finance. Some of the things that we're going to be talking about are finding interest rates, value of money, credit, truth in lending, advantages and costs of home ownership, and some financial investment ideas. So we're just going to go over a little bit of everything just to give you some financial information that might benefit you. So today we're going to be talking about time value of money, and specifically what we mean with that is interest, how to calculate interest, how to calculate simple interest, future values of loans or different information than the present value, compound interest, effective annual yield, which is something to deal with banking, and inflation. So with interest, what interest is anytime you borrow money, the amount that you have to pay back later will be a higher value. And the amount that you have to pay back, the extra amount, is called the interest. So that money gains value over time. Now you can think about this as money that we borrow, we have to pay interest on, or if we think about depositing money in a bank, we're going to gain interest on that money. So there's some positives and negatives in terms of interest. The amount of money that you start with is called the principal, or that's the loan amount, that's the deposit amount, whatever the case is. The percentage rate that you're going to be paid or that you're going to be charged is called the rate of interest, or the interest rate. And that's just the amount that y'all set up. And this is usually an annual interest rate unless somehow it's stated differently. So interest is usually only calculated on the principal. And when it's only calculated on the principal, it's called simple interest. Now, when interest is calculated on the principal plus any other amount that has been added to it, then that's called compound interest. So simple interest is basically you just take the amount that you borrow, you find the interest rate, you add it in, and you divide by how many payments you're going to make. Whereas compound interest, each month that you don't pay off the full amount, the amount of interest is going to be recalculated and it's going to increase the value. So to calculate simple interest, we use this formula. Interest, or I, equals P times R times T, and the principal, the P is the principal amount, that's how much you borrowed, the R is the rate, and T is the time in years. So for example, if it was a 6-month loan, then the time in years would be 6 over 12. If it's a 24-month loan, then T would equal 24 over 12. So when you're using the value of T, or when you're finding the value of T, you always do it over 12 because it's per year. So if we have this example and I want to find the amount of simple interest paid to borrow $4,800 for 6 months at 7% interest. So R equals 7%, which is 0.07, because we have to write it as a decimal. T is 6 months, which is 6 over 12. And P is 4,800. So if we substitute that information into our formula, we end up with 4,800 times 0.07 times 6 divided by 12 is $168. So $168 is the amount of interest that we, in this case, have to pay. So now if I wanted to figure out exactly how much money I'm going to end up paying back on the loan, I would just take that 4,800 and add the 168 to it. So the amount that I would end up having to repay is 4,968. So this total amount that we have to repay is called the maturity value. How much will it be worth at maturity? Now again, you tend to see that word maturity value when we're talking about an investment as opposed to a loan, but that's the same thing. So that amount that we're talking about is called the future value also, or the future amount. The principal is called the present value. So you can think about the P. So principal is the present value. That's how much we started with. And how much we end up paying back, or the final value, or the maturity value, is the future value, or the future amount. So there's another formula that you can use to find the future amount. Okay, so this formula that I'm showing here will find the future value, or the future amount of a loan. In other words, it will find out how much principal plus the amount of interest that you paid back. Okay, so same notations here. P is the principal, R is the rate, T is the time in terms of years, and A in this case is the future value. Okay, so just to clarify one more time, A is equal to the future value. And the future value is equal to the principal plus the interest. That's what the future value represents. So the future value for a simple interest. So here we said find the future value of a $460 loan that you took out for 8 months at an annual interest rate of 12%. So if we use our formula that they just gave us, A equals P times 1 plus R times T. P is 460. 1 plus R is your rate, so it's 0.12. And time is your number of months in terms of years, so it's 8 over 12. So when we calculate all of that, we get 496.80. So again, if I took that problem and I just simply calculated interest, and I did interest, okay, let's start again. If I did interest equals principal times rate times time, I would end up with 460 times 0.12 times 8 over 12. And if I put that in my calculator and did the calculations, I would get 3680. And then I would add that to the amount that I borrowed, 460, and that's where I get that 496.80. Okay, so that's all we're talking about there. All right, so here's another approach to the problem. It says if you can earn 6% interest, how much money do you need to deposit now so that its value will be $3,500 after 9 months? So again, this is what we're asking. I need $3,500 in 9 months in order to pay my tuition. So how much money do I have to put in the bank now so that at the end of this 9-month period of time, it will be valued at $3,500? So that's what they're asking you. They're asking you to find the principal. Okay, so we're going to take our formula again, and since the future value is 3,500, I have to use this formula. The future value is 3,500. The principal is the number I don't know, and then the interest, 1 plus the interest, which is 0.06, times time, which is 9 over 12. I'm going to put this information in my calculator. I'm going to put the 1 plus 0.06 times 9 over 12 in my calculator, and I'm going to get 3,500 plus P times 1.045, round it off a little bit. So to solve for P, or get P by itself, I'm going to divide both sides by 1.045. So the amount of principal that I need to invest right now is approximately $3,349.28. So again, to clarify what we're saying here, how much money do I have to put in the bank right now so that 9 months from now it will be worth $3,500? And the answer to that question is I need to put $3,349.28 in the bank right now, and in 9 months it should be worth almost, or at least, $3,500. All right, so let's look at another option. What if we're talking about compound interest? And compound interest is interest that's added more than one time during the loan. So what's going to happen is, depending on the account or the situation, like every month you might have interest added, or every 3 months or every year we might have interest added. It depends on the terms of the loan. So this is what we talked about. So it can be compounded at different intervals. So semi-annually, quarterly, monthly, daily, and this is called the compounding period. All right, so let's look at our formula for this. A is the future value again. P is the principal, the amount of money that you're borrowing. M is the number of times it's compounded per year. R is the interest rate. And N is the total number of periods of time that we're talking about compounding. Okay, so let's talk about it again. A is the future value, how much I'm going to end up paying back on the loan, including interest. P is the principal. R is the interest rate. M is the number of compounds per year. And N is the total number of periods. Okay, so let's look at this example. Find the future value of an $8,560 loan that's compounded at 4% interest quarterly for 8 years. Okay, quarterly for 8 years. So let's talk about a couple of terms here. Quarterly, if you think about quarters, how many quarters in a dollar? There are 4 quarters in a dollar. So quarterly would be 4 times per year. So if it's compounded 4 times per year for 8 years, then 8 times 4 is 32. There would be 32 periods of time. So if we put all that information into our formula, principal is 8,560, rate is 0.04, the value of M is 4, and the number of periods is 32. So we're going to put all that information into our calculator, and when we work it out, we're going to end up with $11,769.49. So here's what we're talking about again. I borrowed $8,560, compounded quarterly at 4% interest for 8 years. By the end of the 8-year period of time, I would have paid back $11,769.49. So let's look at another one. What amount must be deposited today at 5% compounded monthly, so there will be $18,000 in the bank at the end of 20 years? Okay, so this is again a problem where we're looking for the amount of principal. So compounded monthly is 12 times a year. 20 years would be times 12 times would be 240 periods. So then if we substitute that information into our formula, 18,000 is the future value. I'm looking for the principal. The rate is 0.05. The number of compounds is 12, and it's 240 periods. So I'm going to put all of this in my calculator, and when I do that, I probably end up with a very, very small decimal. So sometimes when you're putting it in, you may have to write out quite a few of the decimal values that you end up with. so that you can get a pretty accurate answer. And we end up with the principal being $6,635.60. So one more time, let's say what that means. I want $18,000 in 20 years. It's compounded 5% interest, compounded monthly. So in order to do that, I'm going to have to put $6,635 in the bank today. And then 20 years from now, that money will be worth $18,000. All right, so let's talk about this, effective annual yield. So a lot of times when banks advertise an interest rate, they will give you two different values. The first is the actual interest rate, and it's called the nominal rate. That's the stated amount that's going to be given to you. The second value is what we call an effective annual yield. And this is the rate that would give you the same final amount or future value at the end of 1 year if it was simple interest rather than compounding interest. And this is called the effective rate or the effective annual yield. Usually the effective annual yield is actually a larger number than the nominal rate, or it's a larger percentage than the nominal rate. So let's look at the formula that we have to calculate the effective annual yield. So Y is the effective annual yield, R is your rate, M is the number of times compounded per year, and you'll notice that M is used twice. It's raised to the M power instead of the N power this time. And then you're going to subtract 1 from that value to find out what the effective annual yield is. So here's an example. What is the effective annual yield of an account paying a nominal rate of 4.2% compounded monthly? Okay, so if we plug all this information in, R is 0.042, and M, since it's compounded monthly, is 12. So we're going to plug all that information into our formula. And we end up with, oops, I forgot the -1 here. And we end up with 0.04, I'm sorry, we end up with 0.42, oh, I had that right to start with, sorry. We end up with 0.0428, which is 4.28%. So again, the amount of money, let's look at that again, the amount of money that the bank is advertising, the nominal rate is 4.2%. The 4.28% represents the rate that would produce the same final amount or future value at the end of 1 year if the interest were simple. So again, just a different, and again, by simple interest rate, that means it's not compounded. We're not, every month, we're not calculating the amount of interest. We're just calculating the interest one time and producing an amount. So the 4.28 would be how much interest would you have to be paid if you wanted to get the same annual yield or the same amount at the end of the loan, the same future value as you would if it were compounded monthly. All right, so inflation. What we're talking about with inflation is this idea of the value of goods increasing over time, or the value of goods decreasing over time, and that the idea that money actually loses value over time. And this term is called inflation. So let's look at, there's some information in your book that you'll need to look at. There's also a table out on Blackboard that has this. If you look on page 696 in your book, there's a table that refers to the Consumer Price Index. And this reflects the prices of certain items purchased by large numbers of people. So it gives you an idea of how inflation has changed over the years. So what you have here is a formula to calculate the future value, taking into consideration this inflation. So P is your principal. E, there is a button on your calculator, and if you look at this button and you press the button and press enter, you'll notice that you get a value of 2.71828. That's the value of E. If you do not have an E button on your calculator, then you will need to actually just type in the number 2.71828. And this is a standard irrational number that it's sort of like pi that we have learned about in the past. It's just a number that's accepted to have this value and can be calculated out. R is the rate, and T, again, is the period of time. So suppose you want to buy a cup of your favorite coffee that costs $2.25. If the inflation rate persists at 2% over time, find the cost of the coffee in 25 years. So if we go through our formula here, A is the final value or the future value. The principal is $2.25. E is that 2.71828 raised to the 0.02 times 25. Now again, on your calculator, you're going to have to do 0.02 times 25 first and get a value for that. Then you're going to take 2.71828 and you're going to raise it to that 0.50 power. Make sure that's right before I... Okay, and then you're going to take that answer and you're going to multiply it by 2.25. Now, depending on what kind of calculator you have, you may have to take this in a couple steps, or you may be able to do it all in one step. So what this tells you is that your cup of coffee is going to cost about $3.71 in 25 years. That same cup of coffee that you're buying now for $2.25. All right, so for a consumer product or service to average inflation, if you're doing a comparison of these two, we have this formula: price for year A, price for year B, consumer price index in year A, and consumer price index in year B. So in order to get these consumer price index values, you have to look at that chart, again, on page 696 to get that information. So here's an example. Your mother paid $3,000 in tuition in 1980 at the same college that you'll be attending and paying $9,300 in 2005. Compare the school's tuition increase to inflation over the same period of time. So again, we're trying to figure out how much my tuition increased in comparison with what inflation really was. In other words, did it sort of stick with the inflation rates that we're used to, or did it take advantage of numbers? So X represents the expected tuition that we would expect to pay in 2005 if it had increased at that rate that we're thinking, okay? So we're going to pretend that we don't know how much the 2005 tuition is, and we're going to calculate the 2005 tuition. Okay, so I know that the 1980 tuition was $3,000. In the chart, if you look in the chart and you look at the 2005 year, you'll see the number 195.3. And if you look in the chart and you look in the 1980 year, you'll see the number 82.4. And so now we're going to solve this by cross multiplying. So we're going to multiply 3,000 times 195.3 and we're going to divide it by 82.4, and we end up with 7,110.44. So if the inflation had been consistent, this is what we would expect tuition to be in 2005. So now the actual tuition is $9,300. Okay, so let me get my calculator really quick and check this number and make sure something is right here. I just noticed there's a typo here, so let's see what we got here. Okay, so we have $3,000 times 195.3 divided by 82.4, and we end up with 7,110. Okay, so what we want to do here is we want to take, oops, I didn't mean to close that. We want to take 9,300 and we want to divide by 7,110.44. Okay, and we get the same number, 1.307, so we'll go with that number. Okay, so it looks like they just typed in the wrong number here. All right, so this number right here, okay, this number right here should not be 7,128, it should be 7,110.44, but you still end up with the 1.30. So what this tells us is that the tuition at the school increased about 30% more than the consumer price index expected to. So that's not necessarily a good thing. That means the school's tuition was increasing faster than it should have for that period of time. All right, so then the next example would be, how many years would it take for the price of something to double? And the formula that we give for that is the years to double equals 70 divided by the annual inflation rate. So if we look at an example, estimate the number of years it would take to double for an annual inflation rate of 2.1%. So we're going to take the 70 and we're going to divide it by 2.1%. Notice that we're not moving our decimal place over. And when we do that, we get 33.33. So that's telling us that it's going to take approximately 34 years for the amount to double, for the item to double. All right, I hope this helps. I hope you have a great week. We're coming to the end of the class. Let me know if you need any help, and we're talk to you later. Bye.